About more game content and management. Went over a little bit about loading some stuff from config when we're dealing with the world itself. I went through the process of defining a JSON file that would describe the world and then how to load and parse that information in. But let's take that a step further and let's expand that to other things we might want to have come from config. Now, this is called like a data-driven design. If you worked with some other utilities like databases and things, that would be another way you would be integrating that data, pulling it from some data source. For our games, mostly what we're going to be doing is pulling it out of some kind of config file or spreadsheet. For instance, we could have data defined in like a CSV or XML or what have you. The idea is that you don't want to hard code everything, so that you can really, let the game designers, which is probably also you in this case, but if you think about working for a larger company, there's going to be whole different divisions whose goal is to define what the content of the game looks like. And so it's going to be our job as the programmer on this to support the loading of that data and then the utilization of that data. And then also then how we're going to organize it in the code, so that we don't have redundant copies of data floating around and probably even some sanity checks. So when I'm talking about game definitions, I'm talking about the things like the items in the game, the weapons in the game, stats, special effects, any kind of metadata on anything that's going to happen in the game. Commodities. I was working on a space station simulator where things I had coming from game definition were the different components of a space station, different facilities that would be installed in those components, spaceships that could be built, and the facilities that would go inside those spaceships, and then commodities to trade, and factions, and AI, and specific like people of interest, and game events, and so many different things can come from game definition. So let me give you an example of what that might look like. So I'm going to go over here and make a new file. I'm going to make it a JSON file, as you can see by opening and closing braces. I'm going to make a folder. Make a new folder for, let's call this defs. Call it, go with the Quake style of it. And I'm going to call this items.def. And the cool thing about this is that I can tell my system to highlight it as if it's JSON anyway to make sure that I have a little bit of a sanity check on the JSON. Like I said, I like to have it start off with my items. And here my items is actually going to be a list. So start off with a list. And then each list is going to be an object. And the object is going to have things like, I'm going to make sure that every one of my things has a name that is going to be easy to search and connect with. So I'm going to start off with what kind of a game? Let's go a simple fantasy RPG thing. So I'll start off with Short Sword. And I like to have a simple, easy to search name, and then I usually will add something like a display name. And display name is going to be, Short Sword. Now, better to see. And then we're going to have like a price, and we're going to set this to like 100 of whatever it's going to be. And then maybe I'll even add a type, and the type is going to be a melee weapon. What else might we define on this thing? Damage. And damage of this is going to be 5. That's probably enough for this. So let's add another couple items. And so we've got short sword, and I'm going to have shield. Let's call it a wood shield. Price is only going to be 50. Type shield. And then we're not going to have damage, we're going to have defense, and we're going to make that defense stronger. And maybe we'll also add something like, say, cooldown. just do one more. Health potion. Type. Potion. 25. And we're going to heal 10 cooldown. It's going to be irrelevant. We don't have a cooldown. It's going to be a single use. Maybe we'll know single use is a thing. So here I have to find some items in the game world. So now let's start defining what that is going to look like in the code base. So let's make an items. Pound if and def items h pound define items h pound and if. Save this into my include. By the way, this is just going to be like one hypothetical style of how I'm going to organize items. There's multiple. Hopefully this is just a starting point to get your creative juices flowing. Now in theory, what I could do is I can now define a type in game for all this information. And then I can make an initializing function that goes through and pulls all this out as I need. Or I could just store this as JSON and access it and search it whenever I need it. So here's what I'm going to do instead. I'm going to do the latter. I'm not going to define a type. I've already showed you what that looks like when I parsed out the world. So for here, I'm just going to start defining some functions that we're going to be dealing with. First of all, I'm going to need a items initialize. And this is going to take a constant char star file name to parse. I'm going to probably need to include here simple JSON.h. I'll make sure that automatically cleans up. And I'm going to have a sjson star items get def by name. Constant char star name. Again, this is going to add brief, initialize, and load item definitions. I can't spell today. Definitions, cool. At param file name, the JSON file containing item data. And now, honestly, we should also probably call that constant because we're not going to change it, but I'm not going to bother. At brief, get an item by its name. At param, the search criteria. At return, null if not found. Otherwise, the definition information of the item. At note, do not free that data. For now, that's probably all we'll need. We might need some additional information later, but let's start making this. Now, include simple logger .h, my end of line at end of file. And let's save this in the source folder as items.c. Cool. Now what I want to do is have a global, a static sjson star item defs. And right now it equal null because I don't have anything here yet. And probably going to make another one just as a let's call it item JSON. You'll see why in a second. Okay. First thing, if not file name, ourselves some error message. No file name provided for item initialization. Return. I'm also going to make another function up here. Items close. This is going to be nothing function. We'll define it down there. At exit. Let's do this at exit. Whatever we create, we destroy. Whatever we load, we free. And all this is going to do is if items.json sj free item.json, and then we're going to set those two things to null. Cool. Now we're going to set item.json equal sjload file name. If not, then we're going to slog the error. I really want to drive this point home. It may be tedious and taking up a lot of time in this video, but I really want to drive it home that you always give yourself an error message. Where anything in your code can go wrong, tell your future self why it went wrong. Game programming is a lot like time travel. You need to follow the rules. And one of the first rules of time travel is always be kinder to your future self. Your future self has been through more crap than you have, so be kinder to them. In this case, we're being kinder to our future selves by giving them error messages to help them solve the problem they're facing. So, failed to load the JSON for item definition. And that's already going to error if the file name, which I didn't spell correctly. The JSON will say it's going to fail to load. We're going to return here. Now what we're going to do is we're going to set item defs equal to sj object get value. And the value I want to get out of this, first of all, what I'm getting it out of is the JSON. Now what value I want to get is items. Cool. If not, then slog item definition file %s does not contain items list. Return. But before we return, we are going to free the JSON we loaded. And we're going to set it equal to null. Then we're going to return. At this point, we can return. That's all we need to do for initializing for now. Maybe we'll do other stuff later on as the code evolves. All right, now get items by name. First thing we have to do is, if not name, return null. And maybe give ourselves an error y. The other thing we need to worry about is this is null. And we're definitely going to error here. No item definitions loaded. Return null. By the way, at the end of this, we're going to return null. Spoilers. We need a counting variable. And I and C. And I'm also going to need a sjson star item. Cool. Now, let's see what this is going to look like. First of all, we need to count of the items. So C equals sj array get count. And the array we're getting it out of, this should be an array because we defined it here as an array. Cool thing about my JSON library is that if this is somehow not an array, this returns 0. And maybe we want to slog here, or maybe we're going to leave it alone, but no item found by name %s. And here we provide it the name. For I equals 0, while I is less than C, I++. So I'll go through the entire array of items. Now we're going to set item equals sj array get nth. We're getting it out of our item defs. And the nth we're looking for is actually ith here. First of all, if this failed to get something for whatever reason, the JSON was misformatted. So if not item, skip the iteration of the loop, continue. Next, we need a item name. So I'm going to set constant char star item name equal to null. And now since this is supposed to be an object, I'm going to set item name equal to sj object get value as string. Yes, it's verbose. I have plans to make shorthand versions of all these functions in my library in the future. But for now, the purpose of writing this in the first place was to get you used to knowing what the hell it is you're calling. So object get value of string, the object we're getting it from is the item, and the thing I want out of it is name. So now I've got my item name. If not item name, if for some reason we had an object in this list that was not formatted correctly, we're going to skip it, because clearly it doesn't have an item, it doesn't have something to compare. And now we can do some checks. So we can do, and I actually wrote, let me go back into my text.h. I wrote these string I comparisons. This ignores case, and this checks to see if length is the same of these two things. So there is a use case where if I'm checking string A and string B, and A happens to be shorter than B, but A is contained as a substring of B, this will return true, or this will successfully match even though I don't actually want it to match. So I added string length comparison, which also compares the length first before it'll determine that these are the same string. So I want to make sure that if I have sword long, sword short, sword extremely large, that they don't falsely match on each other when I'm searching through strings, which is one of the weird things to deal with string stuff. I can't tell you how much I was annoyed when I was taking my beginning computer science courses, how much of the algorithms were based on just string parsing and matching, and only to discover once I've been a professional software engineer how much of my life is still dealing with string parsing and matching. It is irritating. So I got tired of it, so I wrote my own function for it. So this, if they're the same, if they're a different length, we're going to fail. It won't work as an alphabetically sorting use of the string comparison functions, but it will definitely not return 0, which is a match, if they're different lengths. So that's why I want to make sure I'm checking name versus item name. Now this again returns 0, so I actually checked. I don't say if false, I say if it equals 0, because it's not false, it's the return type is match. So if we have a match, then what I'm going to do is return the item. I found a match. It is a linear search. It is O of n. If you think you're going to make this more optimized, you can optimize it by making your list smaller. I mean, honestly, considering how many items are likely to be in a game or anything like this, if we're dealing with something extremely large, then we can store it as a hash map, and in which case you probably do want to parse it. Remember, the hash maps are O of 1 search time once you've made them. So if you have an absurd number of things that you've defined for your game, oh yeah, I've defined over 6 billion star systems from this data set I extracted from NASA, and I want to parse that, then maybe you want to spend the time to go through it once and build the hash map. And then you can just do the hash map search, where we could search by your key value, in which case what you end up getting is an O of 1 search. Optimize when you need to. Don't over-optimize. If you over-optimize, you'll end up spending all your time optimizing, and then sometimes, there's a cost to making a hash map. Is it necessary? How much are you saving? what does your data set look like? Consider the real world implications. The hash map isn't always the correct solution. All right, so there's my search function. Now, what are we going to define items to look like in game? So let's make a new folder, new file. Pound if and def inventory h. And if. All right, save this in my header files. Inventory.h. Now, what is the player's inventory going to look like? This is where you get to need to decide for yourself certain features, like Minecraft style, where things can be stacked, or Quake style, where I only ever have one of a thing, or ammo. Ammo is always kind of its own thing. In which case, what I end up having is an array. So let me type def struct my inventory, and I'm going to have a text line, because I'm not going to, the name of any of my items in my inventory is never going to, actually no, even before this, I'm going to define what a inventory item is going to look like. So type def, oh no, I could just do this. I could just do, as I was saying, for the Quake style, I would just have a int. I'm going to have my items list. And I'm going to have this defined as max items. And maybe I'll pound define max items to be 128. And I'll only ever have 128 items in the game. And then if I want to index into the items, then I can probably do a type def enum. Item types or item indexes. Indices, and I'll have II, short sword, II, wood shield, II, heal potion, II, max. Since we always index from 0, and this will always be that extra one, we can just do here II max, and maybe that's how my inventory happens to be, and then like this just becomes a count of that item. But what if I want some additional information on that item? So let's go back to items.h, and I can define some additional things, like say type def. This is all hypothetical now. Type def struct item type. All we're going to have, this is where I would have the text line name. So I would store the name, which would be a copy of the item name here. And I also need to include gfc text.h to have access to that. And then I'm going to have, maybe the item is going to have a, maybe the item is going to have a count. How many of the item I have. And maybe in my items definition, I add a new flag here, which is stackable, with defaulting it to 0. So that I can say, hey, is this stackable? And then if stackable, when I pick up another one, we can, if stackable, do I have one? If so, add the count. If not, fail to pick it up, or if I don't have it, then I can add it to the first time. Or I could have, for instance, what did I call it? I think I just called it list. I should have prefixed it GFC list, but I didn't. And now we're going to define here, or include here, pound include, and this should be before my define there. Pound include GFC list.h. And it would be instead of this. And maybe I have something like, say, a weight limit
hypotheticals.
And then when I would add items to the inventory, so I would probably have a void inventory add item, and I would have to take a pointer to my inventory. So the player's inventory, or maybe I would have an inventory. I could get double use out of this for things like treasure chests. Inventory star inventory, and then the item I'm going to pass in as a constant char star name. And now let's go to, I probably need a inventory star, or maybe void inventory init. Inventory is one of those words, the more you type it and say it out, it gets weird. I'm not going to bother commenting all of this because this is all still hypothetical code. This is meant to inspire you and give you direction, not give you code that to just copy paste and call it done. End of line at end of file. I'm also going to include my inventory.h. Save. This goes to my source folder. Paste. So the idea behind this is that my inventory system has a pointer to something that has to be initialized. So if not inventory, return, nothing to do. Otherwise, I'm going to set my inventory items list equal to GFC list new. And if I make an init, I need to have a close. We create, we destroy. If not inventory, return. And then I'm going to need to clean up my inventory. So where's my items list? No, there's my items list, items.h. So I'm going to need a couple other things here. I'm going to need a item star, item new. Maybe I can even pre-populate that based on a name here. And then I'm going to have a void item free, which is going to take an item star item. We can define these. Cool thing about making this as a video is that I can go as fast as I can. You guys can just slow this video down or pause it whenever you need to. We can see how this is just evolving into something. So let's get the sjson star item def equals items get by name. If not item def, return null. We failed to get it. We're already erroring, so that's great. Item def, oh, item. I need an item now too, so let's do item equals and GFC allocate array size of item, and I want 1. If not item, return null. I should probably error message there. I'm not going to for now. Then I can do, where's my text.h? Copy. No, I want line copy, not word copy. I'm going to copy, and I believe it's destination comma source. So I'm going to go item, name. Maybe, what else? What kind of information might I want to pull out of here? Where's my items.h? Count item. maybe price is something I keep, just as an example of how I would pull that out of definition when I need it. And then, so what I would do is, this is already initialized to 0, so my price is defaulting to 0, so I would do sj object get value as int. And the object I'm getting it out of is item def. And the thing I want out of this is price, and then I called it price. I need a pointer to item price. All right, cool. Just an example, I would then get other relevant but change or other default values. I'm using price as an example. Maybe hypothetically, the more you use an item, it'll wear and tear and its price will come down. Or you can enchant it or whatever else. This is just defaulting states. And I'm just going to return item. Remember, I'm not freeing item definitions. I don't own it. It's owned by the system. Now, item free. So I've created this item. I'm now going to, let me set my count also. To item count equals 1. So item free, if not item return. Now what have in my item type do I define? Nothing. Nothing here has to be dynamically allocated. So I don't even need to worry about this. So I'm going to call this and, oh, here's another idea to add to the items definition. I might have the sprite. And the sprite might be defined by the file name is images items list. Frame. Maybe that's .png. Frame 1. And all the other stuff that would come into the play with that. Maybe I would possibly load the sprite here as well. And so my items type, maybe I do have a sprite star sprite. And then I would want to include IGF 2D sprite.h. In which case my item free now would be GF2D sprite free item sprite, and then I would free the item. There, now that's cleaned up. Now whatever I would have allocated, I would have now cleaned up. I'm not going to go through the process of parsing out a sprite. I should have had to do that with the world loading. So here in inventory, now we have a list to free up. Now I could either iterate through my list or I can use one of my iterators. So I've got a for each, and it's a function that takes a pointer to something. So I can use my for each here. Oops, rename this file. Yes, save, please. I can do for each. The list I'm going to be doing is my inventory items list. And the function I want to call is, so this is a case where I'm probably going to need to include my items.h. And I want to call items free. So each item in my list is going to be called with items free. And that's going to work because what I can do is I can cast this as my type, my work function type. I've defined this work function, so I can cast this as a work function. Might have to add a star there. find out when I compile it. So this is a for each. So this will do for I equals 0, I is less than the items count, I plus plus, and then it will call for each item in the list this function, providing it the pointer of the item list for that. And then what I can do is I can GFC list, I would call it delete. And I can delete this. And then I can set this equal to null. Now it's cleaned up. And the add, the opposite of this, or same thing, we're going to have to make sure we have an item or an inventory. If not inventory or not name, return. Otherwise, what we're going to do is get an item pointer, item star item. Item equals item new. What did I call it? Oh, right. New that item. If not item, return, nothing to do. It failed. And then I'm going to do GFC list append my inventory items list is the thing I'm adding to it, and item is what I'm adding to it. And that's it. In theory, if I have a count, what I can do first is check to see. So now here's where I would have an item inventory search. I would have a item star inventory get item by name. Constant char star name. Int I, C, item star item, C equal, actually, right here, first check, return, in this case null, return null as the final case. C equals GFC list get count inventory items list for I equals 0 while I is less than C I plus plus. I write this very line of code so many freaking times. Now item is going to equal GFC list get nth. This is exactly the same design pattern as the JSON array. In fact, it's the same code base underneath. I just made it generic for list. I wrote it actually first JSON first. And again, both of them are based off of glib's glists. So credit where it's due. If not item, continue, skip the list. And here's where I would now once again do my string comparison. If this equals 0, then I'm going to return item as I found it. And we're checking item, name, and the name of that. Now I've got a search feature for my inventory. So first thing I want to do before I even make an item is item equal get item by name. And now if item, and what I would do here is just set item count plus plus. No need to add a whole new one. We already have it. Return. In theory, you can have an item inventory remove item, and it's going to be the same thing. Do I have it? If so, decrement to count. Maybe if my count is now 0, I delete the whole thing out of the list. It's up to you how, if you want any dangling entries in your items list, but that's how you would do an inventory system. It's also how you would do just any kind of generic definition system for things in your game world. This is dummy code. It wouldn't do anything. I don't have any use cases to really work with this. But hopefully this gives you some design patterns to work off of as you go forward, designing not just your inventory system, but whatever else is going to be in your game. Your entity definitions can come from definition. Just like remember Quake. Everyone moans about Quake 4 because it's extremely overly abstracted with all the inheritance, and it's a lot of moving parts, and it's complicated, and it doesn't feel like we can get as much done as we could in Quake 2, but it did have some design patterns to learn from. This is going to be one of them. So like right now we have the player.c. What I would probably do here is do a type def struct, and I would call this player data. And then maybe here I would have an inventory, not a pointer. Now I would also need to include inventory.h. And like I've said in the entity system, I have this void data and I have a free function. So for now, my free function doesn't do anything, but now what I'm going to do when I make a new player is I'm going to set, I don't have to actually set it. Well, no, what I need to do is I need to do, I need to make a player data function, and maybe I have other information in here as well. Let's call this int level, int experience, text line, class name. No, so now I've got a bit more player information. So my player new, what I'm going to do is define my player data, star data, data, we'll do it at the end. Data equals GFC allocate array, size of player data, I want 1, if data. This is a case where I don't want to short circuit the whole function if this failed. Actually, yeah, I do. Doesn't matter. Skipping that for now. I then want to set self data equals data. But now this is a void pointer. It has no type association with it. This is the type associated data type. So what I can do here is now do my inventory init. And I'm going to do that on my data inventory. And all that's going to do is allocate the array. And now my cleanup would be, I would need a player data pointer. Here. And then I would set data equal to self data. And if I want to be explicit and avoid extra warnings, I can make sure that I'm casting it as a pointer to player data. Otherwise, it's identical. Like this, without this, the compiler will warn at you. With it, it fails too. I got tired of typing this out, so I configured my compiler to not warn about that. But the default thing in Windows does warn about that, which is why a lot of my code warns pages and pages on Windows. If not data, actually here, if not self or not self data. So before I even do any of that. All right, so now that I've got this data, now I'm going to free my inventory, or clean up my inventory, since the inventory itself doesn't get cleaned up, but the items in my inventory do get cleaned up. So this is going to be my data inventory, which, by the way, not a pointer, it's the data. This needs the pointer, this needs the reference. So the address to my inventory. Now that that's cleaned up, I can now clean up my player data. So here's where I now free my data. The free needs its type association with it, if I remember correctly. So make sure you give it the cast as its type pointer. Don't just free that. Although in theory that should be stored internal with it. So never mind that last part. All right. Let's see if this one. How many typos did I make? Oh, yeah, there's one of them. Inventory.c line 16. How come someone didn't notice that? You should have spoken up. Inventory.c line 33. Yeah, it did need the star after that to make sure it's a function pointer. Items.c line 4. Oh, which probably means it's in the header file. Oh, I probably also never included. I never included items.h. Is where I included JSON. Cool. Oh, look at that. Items.c line 84. All right, there it goes. And just to make sure that the game works. It allocated the inventory, and it cleaned up the inventory, and it didn't crash. All right, that's enough for this video. Hopefully this will be a good starting point to start integrating definition-driven design and start thinking about how you're going to store your inventory, defining your entities, and everything else that goes in this crazy game. If you're feeling overwhelmed, that's normal. It'll all come into focus, don't worry.